Let's look at today's notes. So this is all about geometric sequences. On the last lesson, we learned about arithmetic sequences. So arithmetic sequence is whenever you add or subtract a number to each of the previous term of the sequence, and you're able to get an ordered list of numbers. So that's arithmetic. And this is our formula. We find D, which is our common difference. That's basically what the pattern is. Yes, we'll always use D whenever it's arithmetic sequence. So we are now going to look at geometric sequences. So this is similar because there's a pattern, but instead of our basic add, subtract, it's going to be multiply and divide. So a geometric sequence is an ordered list of numbers found by multiplying or dividing. So when we did arithmetic sequence, we did an ordered list of numbers found by adding or subtracting the same number over and over. Well, this is you're multiplying and dividing over and over and over. We are going to find this by using a ratio. The ratio is called the common ratio, like common difference, but this is going to be common ratio. And you can find this term. So it's going to be R equals your second term divided by first term. So sometimes you'll see this as A2 divided by A1. With geometric sequences, we can use G sometimes. So this tells us the geometric formula is AN equals G1 times R raised to an exponent of n minus 1. Sometimes this is a G sub n instead, because A really stands for arithmetic sequence. So this probably should have been a G sub n, and then this was G sub 1. That means your first term of your geometric sequence.
What does the R mean?
R is your common ratio. It's the number that's being multiplied to get to the next term, and then the next term, and the next term of the sequence.
Okay.
So A sub n or G sub n, that is your nth term.
Nth?
So I could say my 50th term, my 30th term, my 61st term, whatever term you're looking for. And then AN or GN, that's your first term. And then R is your common ratio. So let's say our first example is going to be 1, 3, 9, 27. Let me do one more. 81.
Oh, they're all divisible by.
So what is the pattern going from one to the next to the next? Now you can tell me. Times 3, right. So times 3, times 3, times 3, times 3. So our common ratio R is 3. Our first term is just 1. So we would say G sub n equals our first term. This is A1 or G1. So that'd be 1 times 3 raised to the n minus 1. So just like with the arithmetic sequence, we're able to plug this into y equals and use x as our variable and look at the table of values. So put that into y equals in your calculator. When we look at our table, remember if this is wrong, you can hit second window and ask it to start on 1. So that was second window and put the table start at 1. Now go back to the table. See how our y's is our sequence 1, 9, 3, 9, 27, 81. See how it's exponentially getting larger and larger and larger? It's pretty cool.
Picks up pretty fast too.
Yep, it picks up real fast. So this kind of growth is actually called exponential growth, and we're going to learn about that in the springtime.
I got a question.
Just wait. Okay, so let's look at our next couple of examples. So number 1 says find the next 3 terms in the geometric sequence. That's all it asks us to do. But we're actually going to find our common ratio also. So let's look. Before we start figuring out what our common ratio is, let's think about what we see in this pattern or this sequence of numbers. It is, the numbers are going down, but what about the negative here?
They're unwanted. What?
Yeah, this one's positive, right? Then this one's negative. This is positive. So the sign is alternating. So that's our pattern, part of the pattern anyway. Negative, positive, negative, and so on. Mm-hmm. And so the way that it does that, or the way that we can find out how it does that, is by finding our R, our common ratio. You find that by dividing. So remember how I wrote this over here? Second term divided by first term, that's our common ratio. So it'd be negative 216 divided by 648. And I want to write it as a fraction though, if it's a decimal. So negative, well, I can do it as alpha y equals and do it as a fraction. So negative 216 over 648 equals negative 1/3. So that's what our common ratio could be, but only if that pattern continues. So we need to double check that that is truly the pattern. So we do that by doing 648 times negative 1/3. And that works. Times negative. I'm going to put it in parentheses. And then I'm going to multiply negative 216 times negative 1/3. And it's 72. So that means the next one I can do 72 times negative 1/3. So I'm going to just put the times, and that's saying the answer, 72 times negative 1/3. So that's negative 24. Keep on following that same pattern. So times negative 1/3, positive 8. And then since I put in what I did previously, I can just hit enter. Y'all watch my calculator. Once I hit enter, it's going to multiply 8 times negative 1/3 without me even putting that in. And so our final term for our next three terms is negative 8/3 and then dot, dot, dot. So I found the next three terms of the sequence, and we found our common ratio. So let's write that out here. R equals negative 1/3. To see if that's a pattern, you would look at what the original numbers that they gave you. So you do it to all of those numbers.
Yeah, but like after that,
you don't have to do anything else. Because this just asks what are the next three terms. So see how I just found the next three terms? So that's all we got to do. All right, let's look at the second one. We're going to do the same thing. Let's look at what these numbers are. So 25, negative 5, 1. So the signs are changing back and forth. So this is a positive. This is a negative. This is a positive. So the next one will be negative. Then we'll have a positive. Then we'll have a negative. So we need to find out what the pattern is. So to find the pattern, we're going to do our second term divided by our first term. So this, I'm going to write over here. M equals negative 5/25. Negative 1/5. So we need to make sure that that is the number that's being multiplied to get the next number and the next number and the next number. So times negative 1/5. So 25 times negative 1/5. And that equals negative 5. So we did it right. Now let's do the next one. 1 times negative 1/5. And that worked too, right? Oh, I was supposed to do negative 5. Sorry. Negative 5 times negative 1/5. And that equals 1. And that is the next term of the sequence.
do you have to keep it as a fraction, or can you change it to a decimal?
I want y'all to keep it as a fraction. So then we're going to keep on following that same pattern. So multiply the next term 1 times a negative 1/5. So I'm going to just put times because 1 is my next term. And then do negative 1/5, which gives us negative 1/5. And the next one, we're going to do that times negative 1/5. If you just keep on hitting enter, it'll do the pattern for you. So I've already got this in. Whenever I push enter, it's going to repeat the operation that I previously did, which is whatever the answer was times negative 1/5. So watch how I push enter and what happens. It multiplies this times a negative 1/5, which is 1/25. 1/25. Then I'm going to do it again. So times negative 1/5, negative 1/125, comma, dot, dot, dot. Dot, dot, dot means it goes on and on and on. So then our common ratio R is negative 1/5. Okay, the next example says write an equation for the nth term of the geometric sequence. So let's see. We need to do g of n equals g of 1 times r raised to the n minus 1. That's the formula from over here. So our g of 1 is our first term. So this is g of 1. Now we need to find r. R is found by dividing the second term by the first term and then making sure it follows that same pattern. So we want to do r equals, so 10 divided by negative 2. Negative 5. So then we just want to make sure that of the numbers that we have, that it follows that same sequence. Negative 2 times negative 5 is positive 10. 10 times a negative 5 is 50. So that's right. We could keep on doing that same pattern. Negative 50 times negative 5. But it doesn't ask us to. But that is 250, isn't it?
Mm-hmm.
Okay. So let's write our formula. So g sub n equals g1. I'm going to put in parentheses, negative 2, times r, negative 5, raised to the n minus 1. So let's look at our calculator. So it'd be negative 2 times negative 5, and then x minus 1.
If you actually put x negative 1, but somewhere.
Nope, you got to put minus in there. Because then that's like saying x times negative 1 instead of x minus 1. Okay, so look at the table. So let's look at our numbers. Negative 2, 10, negative 50, 250. So it's exponential growth. Okay, do any of y'all watch Price is Right? Have y'all ever watched that? Okay, it comes on at 10 o'clock every day during the week. Well, we record it so that we can watch it at night because it's family appropriate. You know, there's so many things that are not appropriate on TV now. So we watch that as a family. And last night we were watching Fridays because we hadn't had time all weekend. So we were watching Fridays. And it was this game called Put the Product. I don't know what it was actually called. But the name of the game or like yeah. So you have all these products. You have a list of prices. And you're supposed to put, you know, the product above the price.
Oh, that's easy.
Okay. So, and it was just for cash. It wasn't for a prize. It was for cash. So at the bottom, it said, if you do this first one, which was the easiest one, it was yogurt for 79 cents. Okay. So cheapest product, smallest product, like that match. That was easy. You won $1,000. You could stop at any point. Okay. The next one, I don't remember what it was. I need to pull it up for y'all to watch it. I know I should pull it up for y'all to watch. But the next one, I forgot what it was, but it was like, if you get this one right, you get $2,000. And then the next one, if you get that right, it was $4,000. Then $8,000, and then $16,000. So it was really awesome because he could stop at any point, but it followed that pattern: 1,000, 2,000, 4,000, 8,000, 16,000 is what he could win. So it was basically double or nothing. If you lose, you're done.
Did he win?
He won. I was so excited for him.
He got 16,000.
He got 16,000. He did not stop. He was like, "Let's go."
We might as well. I mean, you came there with no money. Might as well try and
Might as well, yeah. So it was really awesome. I need to show y'all tomorrow. I will look up the clip and I will show y'all. But I was like, "Oh my gosh, that's what I'm teaching." geometric sequences. You know, because my mind is always thinking about math and class and algebra. All right, let's look at the next page. So we are going to have to determine whether a sequence is arithmetic, neither, or geometric. Okay? So arithmetic has some kind of add or subtract pattern. And so an example, let's do 5, and let's add 5 every time. So 5, 15, 5, 10, 15, 20, and so on. So geometric is a multiply / divide pattern. Wow. Yes, if it's divide, it's a fraction. That's exactly right. So if it's following like halves, let's say it's 100, 50, 25, 12.5, and so on. So your R would be half because you're multiplying times half, which means you're dividing by 2. And then neither, of course, it just means no add, subtract, or multiply, divide pattern. But I'll show you an example. It has some kind of pattern, but it's not add, subtract, multiply, or divide. So an example would be 0, 1, 1, 2, 3, 5, 8, 13. See if y'all figure out what the pattern is.
Oh.
No, there is a pattern. It's just not add, subtract, multiply, divide. It's something with the previous. Any idea? Yes, you're right. It adds the previous number. So 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 3, 5. 5 plus 3, 8. 5 plus 8 is 13. So it is a pattern, just not what you would expect. No, it's a special pattern. I'm trying to think of what it is. I can't remember the name of it.
It's the neither pattern.
No. All right, so what I want y'all to do is decide whether it's arithmetic, geometric, or neither, and then find D, which is a common difference of arithmetic, or R for common ratio for geometric.
We don't solve it, right? Should we solve it?
You're just saying arithmetic, geometric, neither, and then saying D equals this or R equals this. That's it. Okay, so hopefully you had time to finish the examples. Here are the answers. I do want to talk about this last one real quick because it is a neither, but they are special numbers that you might see again as a pattern. Do you know what 4, 9, 16, 25, and 36 have in common? What kind of numbers they are?
Prime.
No.
No, they're not prime.
No.
They're the other opposite.
Yeah, the opposite of prime.
Real.
So you're adding
You're adding the odd numbers.
odd numbers. There's actually another pattern that is. What's 1 squared?
4.
1. What is 2 squared?
4.
It's 3 squared.
9.
4 squared.
16.
5 squared.
25.
6 squared.
36.
These are the perfect squares listed as a sequence. All right, let's look at y'all's assignment. We are only doing the maze side. So let me read the instructions to you. Solve each sequence beginning at the star and ending at the explosion. So this is number 1. First, find the common difference or common ratio. So you're either going to say D equals or R equals. And decide the sequence is arithmetic or geometric. Write the common ratio or difference in each box and color in the type of sequence it is. You're going to follow it around until you end at the explosion. So you will look at what is the pattern and do each numbers follow that same pattern, then write D equals this or R equals that, and then go the direction. If you end up without doing all the problems, you did something wrong. You're going to end up doing all the problems, but you need to know what pattern you're doing them in.